Geothermal energy. How does geothermal energy work? The method for using geothermal energy is quite simple. One or more boreholes are drilled into the underground reservoirs. Hot water then naturally flows or is pumped up to the surface and is then used in a steam turbine to generate electricity or for directing heat. Places that are near tectonical boundaries like Japan and Iceland have many places where the boreholes can reach very high temperatures and pressures. But because of the drilling cost, only only 6 kilometers of the Earth's crust is generally considered for geothermal energy projects. The lower temperature reservoirs cannot be suitable for producing electricity, but they are instead used for heating water to our homes.
Different types of geothermal power plants.
We have a dry steam power plant, a flash steam, and a binary cycle. Dry steam power plant are the simplest of the three designs. The steam goes directly from the production well into a turbine and is then condensed into a liquid and is pumped down through the injection well. The flash steam power plant is where the hot water is depressurized into steam, which is used to drive the turbine, and then the steam is condensed and pumped down through the injection well.
The third design is known as binary cycle system. Hot water is passed through a heat exchanger, where it heats another liquid in a closed system. The liquid has a lower boiling point, so it's easier to turn into steam to run the turbine, and then it's condensed so it can run through the cycle again. Advantages. Advantages of geothermal energy is that geothermal energy doesn't produce any pollution, and it has a very low running cost once the power plant is established. Disadvantages. It's difficult to find suitable sites for geothermal power plants, and the hot rocks have to be of the suitable type and depth, and the rock above them had to be soft enough to drill through. And if not carefully managed, a borehole can run out of steam and may not be usable again for several decades. Occasionally, dangerous gases and minerals can come out of a borehole and make it difficult to dispose of them. An extreme example happened at a borehole drilled at Krafla in Iceland in 1977. Rising magma entered the borehole at 1,138 meters below the ground, and within 20 minutes 3 tons of magma had erupted through the hole.